You know, the AI revolution, it's really being fought on two totally different fronts. On one hand, you've got this massive, high-stakes war between the tech giants. We're talking data centers the size of football fields. But then there's this other revolution, a much quieter one, that's happening right on our own desks. And today, we're going to dive into both of these worlds.
All right, so here's the game plan. We're going to start with that big battle for the data center, and then we'll see how all that power trickles right down to your desktop. After that, we'll get into the one rule, and I mean the one rule you absolutely have to know to build your own AI rig. And finally, we'll look ahead, because what's coming next is a total game changer.
Okay, first up, the new AI chip war. For what feels like forever, one name has just dominated the entire world of AI hardware, right? NVIDIA. But things are starting to change. The ground is shifting under their feet, and for the first time in a long time, a real challenger has stepped into the ring. And this quote really gets to the heart of it. See, for years, NVIDIA's biggest weapon wasn't even its hardware. It was its software, CUDA. Think of it like this impenetrable castle moat that locked everyone into their ecosystem. If you wanted to do serious AI, you had to use NVIDIA. But that moat is starting to dry up. Thanks to open source tools like PyTorch that can run on pretty much anything, that lock-in is weakening, and that's cracking the door wide open for some real competition.
And here is that challenger. AMD's brand new Instinct MI355X. Now look closely, because they're not just trying to go head-to-head on raw power. No, they're being way smarter than that. They're making this brilliant strategic move, targeting NVIDIA's Achilles heel, memory. They're packing a massive 288 gigs of VRAM into this thing. That is 1.6 times what NVIDIA's offering. AMD is hitting them exactly where it hurts.
So why is that such a big deal? Well, it's because the entire market has shifted. Think about it. For the last few years, the big challenge was training these giant AI models. But now, the biggest demand is for running them. That's a process called inference. And inference is just incredibly thirsty for memory. And that's why AMD's strategy is so clever. It lets companies like Meta and Microsoft run these massive models way more efficiently. And, at the end of the day, that means cheap. Okay, so that's the war happening in the cloud. But believe it or not, this clash of the titans has a really direct and pretty exciting impact on what you can do right at your own desk.
So what does this big war in the data center actually mean for you? Well, it means that the very same arms race, that constant push for more power, more memory, more efficiency, is making consumer hardware so powerful that you can actually run these amazing open-source AI models on a PC you can build yourself. The tech is coming home. And that brings us right to the new generation of hardware. NVIDIA's upcoming RTX 50 series. You have to understand, these cards are not just a little yearly update for gamers. No way. They are a massive leap forward for personal AI, and they're benefiting directly from all that R&D that's going into the data center war. So here's a quick look at the new lineup. You can see the different models, the prices, but I want you to focus on one column here, because there is one spec that matters more than everything else put together. It's the golden thread that connects that huge data center war all the way down to your desk, and that is VRAM. All right, so let's talk about the VRAM rulebook. Because honestly, if you want to understand how to pick the right gear for your own AI machine, you only need to get one core concept. I mean it. You can forget almost everything else for a minute. It is all about memory. Okay, so what is VRAM? Look, in gaming, more VRAM is like a nice bonus. It makes things smoother. But for AI, it's a hard wall. It is not a suggestion, it's a requirement. It's literally the digital desk space where the AI model's brain has to fit. And if the brain is bigger than the desk, well, you can't run the model at all. End of story. Now, what's so cool is that there's actually a simple formula for this. This is the golden rule that lets you figure out exactly how much VRAM you need for any AI model. But look at the example. A 70 billion parameter model, that needs about 168 gigabytes of VRAM. That is way, way more than any consumer card has. So that raises a big question, right? How is any of this even possible on a desktop? Well, the answer is this little bit of magic called quantization. This is the secret sauce that makes local AI work. Here's how it works in a nutshell. You basically reduce the precision of the numbers inside the model's brain. You're kind of rounding them off. And by doing that, you can shrink the model's memory size by up to 75%. And the best part? You only lose a tiny, tiny bit of quality. This is how you can cram a 42 gigabyte model onto a card that only has 16 gigs of VRAM.
It's a total game changer.
Okay, so now that we have our two golden rules, right? VRAM is king and quantization is our best friend. So let's move from the theory to the real world and see what this new hardware can actually do. And the performance jump is just staggering. Just look at this. Running a Llama 3.1 model, the new RTX 5090 is over 50% faster than the 4090, which was already a beast. That number, tokens per second, that's basically the AI's thinking speed. It's how fast it generates words. So a jump like this is the difference between having a snappy, fluid conversation with your AI and that frustrating, type, wait kind of lag. But here's a pro tip. You don't actually need to shell out for the latest and greatest. This is where our golden rule really comes into play. For anyone on a budget, an older, used RTX 3090 is still an amazing deal for AI. And why? You guessed it, VRAM. It's got 24 gigs. Sure, it's a bit slower, but being able to run a bigger, smarter model is often way better than running a smaller model just a little bit faster. Once again, VRAM is king. So, to wrap this part up, if you're thinking about building your own rig, just keep these 4 rules in mind. 1. VRAM over everything else. It opens up your options. 2. Quantization is your best friend for squeezing in bigger models. 3. Memory bandwidth. That's what's going to determine your speed. And 4. Stacking multiple consumer cards is tricky. You're not going to get double the performance.
All right, we've seen what's happening on the desktop. Now let's zoom all the way back out to the data center. Because if you think what we've talked about so far is a big deal, what's coming next is on a whole other level. 90%. Just look at that number. That's it. That's the whole story. NVIDIA's next big platform, codenamed Rubin, is promising to reduce the cost of running AI by 90%. Let me say that another way. They're making AI 10 times cheaper. This isn't just an improvement. This completely rewrites the rules of the game for basically every company on Earth.
And this is where our two stories, the data center and the desktop, finally merge. Think about it. At the exact same time that running massive AI models in the cloud gets 10 times cheaper, our personal computers are becoming powerful enough to run amazing models for free. When that happens, AI stops being this niche, expensive tool for big companies. It becomes abundant, it becomes accessible, it gets woven into the fabric of everything. And that leaves us with one last, kind of mind-blowing thought. As the cost of AI, both in the cloud and on your desk, races towards zero, we're doing more than just making tech cheaper. We are fundamentally changing the economics of intelligence itself. So the real question is, what new possibilities open up? What happens to our world when sophisticated, complex problem-solving becomes, well, basically free?